This is Algebra 2, Lesson 27 on page 125. Rational expressions. What is a rational expression? Yes. No. Correct. So there's a numerator and denominator. It's when a ratio is written as a fraction. You can have a single number over another single number. You can have a polynomial over a polynomial. And anytime we have a rational expression and there is a variable in the denominator, then the graph does something strange. The graph of rational expressions does something very strange. Either there's a hole in the graph where that denominator is equal to 0. There could be a jump in the graph. That's the rare case probably. Or there could be something called asymptotes. Asymptotes, which we're not going to learn, but I say these words this year because that is what pre-calculus is learning today. It's all rational expressions. So anytime we have an x or a variable in the denominator, the graph is not what's called continuous. Here's continuous. That's continuous. This is continuous. It's called continuity. You don't lift your pencil off of the paper. So this is what we graph when we graph a polynomial. When we graph a rational expression, it may look like this. There's a hole in the graph, and then it goes forward. This is where the denominator equals 0. There may also be an asymptote. Like your graph may go like this. And there may be this imaginary, an asymptote is like an imaginary line that the graph approaches but never crosses, particularly if it's vertical. So rational expressions change functions or equations from being continuous to being broken. All right? We are going to learn how to add just ratios, rational expressions. But in your mind, you're already going to take note that when there's a variable in the denominator, it affects the graph. Something is broken in the graph, right? It's not continuous. All right, so look at example 1 on page 125. When I have no equal sign, what is my rule? Or the rule of algebra? No equal sign, Tres.
Create
Common denominator. And that is true in every math course, common denominator. And so if we are to combine these two terms, we have to go to a common denominator. We've worked on common denominators, but they have been easier than this. At this point, now we have a binomial in the denominator. Before, all of our terms were simply multiplied. So what would be my common denominator for these two terms? Yes, Abby?
It would be x squared plus xa.
Okay.
The x on the outside, so just x times x plus a.
X times x plus a. You take this term and you view that binomial as a single term. Got it? So my denominator is going to be x times x plus a on both sides. And I like to go ahead and write that, because then it tells me what must I do to this denominator to make it look like this. And I can only multiply by what if I have an expression? what's effectively 1. That is the rule. So what must I multiply this fraction by to get this in the denominator? X plus A. That's right. X plus A over X plus A. So when I distribute the 4 to both of those terms, I end up with 4X plus 4A. What do I multiply this second term by, Sarah? X over X. So that I end up with 6X. Once I have a common denominator, what can I do? Yes, Nora? I can move that sign to the numerator and add my like terms. You're exactly right. If it's a plus sign, it doesn't change the sign of any of the terms in the second polynomial or the second ratio. But if this is a negative, remember what it does. It distributes to every term. We only have one term. So really, I just move that sign to the numerator. I don't have to distribute the denominator. Guys, you do not have to distribute the denominator. Yes?
If you did have a negative for that second term, what would happen to the denominator?
It remains the same.
So it'd just be negative X times X plus A, and that'd be enough?
No, I would always move the sign to the numerator.
Okay.
Because every fraction has 3 signs. Every fraction is 3 signs, right? I only change that this one goes with the numerator. We just move that sign to the numerator. It's as though it goes, I'm moving it from here to here. I can't move it here to here and here to here because then I've changed 3 signs. So it only applies to the numerator. All right, then we combine our like terms and we have 10x plus 4a over x times x plus a. This is foundational for what is to come. All right, that's the easiest example. All right, let's look at 27.2. And tell me how 27.2 is different from the previous example. And I like to leave space in between all of the terms. How is this one different from the other one? Therese?
You have an X squared.
Okay, I do have an x squared. Anything else? Yes?
No, you have 3 terms in this one.
I have 3 terms. What else? Yes, sir?
One of the terms doesn't have a denominator.
One doesn't have a denominator. So you should always just see that one term as over 1. All right? And then we see each of our denominators as individual terms, right? So what would be my common denominator, Jaden?
X squared times X plus 4.
Yes, x squared times x plus 4. We do not have to distribute it. All right, what must I multiply this first term by so that my denominator looks like this, Nora?
X squared.
X squared over x squared. I think I will distribute the numerator, and that is typical in future courses until we get to trig. You typically do distribute the numerator, but I rarely distribute the denominator. Okay? All right, so this is going to be x cubed plus 2x squared. All right, what do I have to multiply this term by, Nathaniel?
X squared times x plus 4.
Yes. So I'm really going to see this as 6x squared and distributed. Make sense? So when we distribute the 6x squared to x, it becomes 6x cubed. and then to 4, it becomes 24x squared. Michael, what do I have to multiply this last term by?
X plus 4.
That is correct. And distributing the 2, it becomes 2x plus 8. Now that I have all common denominators, I can move the signs to the numerator, and then I will combine like terms. Do not be lazy and not write these steps. Now I combine like terms, because it does get more complex in your higher level maths. I don't know, I just like to draw marks over my like terms. So I end up with 7x cubed. How many x squareds do I have? 26. And then I have a 2x and an 8 all over x squared times x plus 4. And that would be your final answer. Make sense so far? It's what we've done before, just a little more complex. The last example is probably closer to what you will work with in your higher level math. It is. All right, I want you guys to tell me what is different about this example compared to the previous 2 examples. Yes, Ashley?
I have like a trinomial.
I have a trinomial. Okay, you know how we learned factoring before this lesson? We're going to factor, see if we can factor the trinomials. See if they have any like terms, because this is multiplied by this, right? We're going to look for like terms. In the same way, if I have 1 over 6 plus 1 over 12, what would be your common denominator? 12. Why? Because this is 2 times 6, right? 12 is 2 times 6, right? So I only need to multiply this one. They both have 6 in the denominator. I only need to multiply this one by 2 over 2. In the same way, if I have 1 over x plus 1 times x plus 2 plus 3 over x plus 1, do they have a common factor? Yes, this x plus 1 is a common factor. I only need to multiply this second term by x plus 2 over x plus 2. Does that make sense? Okay. All right. So, Will, what are the factors of this denominator? What are the questions I ask myself?
What do you multiply to get C that you can add to get I with B?
Correct. And what is it?
Positive 3,
Positive 3, positive 1. Now, do we have any common terms in the denominator? Yes, we do. X plus 1 is in both of the denominators. You see that? So, Jesse, what would be my common denominator?
X times x plus 1 times x plus 3.
That's right. I need every term. I need this one that they have both in common. I need this one that only one has. And I need this one that only one has. Does that make sense? It's going to be x. Maybe I should write that down a little lower. X times x plus 1 times x plus 3. I don't need to distribute that. X times x plus 1 times x plus 3. What must I multiply this first term by to get that denominator? Say it. X over x. I'm not going to distribute the denominator. I am going to distribute this to the numerator. So we end up with x squared plus 2x. God bless you. What must we multiply this second term by? X plus 3 over x plus 3. And I will distribute this to the 1, which is just x plus 3. All right, now we have a negative. When that negative moves to the numerator, it is distributed to every term in the numerator. So that negative goes to x, that negative goes to 3. So we end up with x squared plus 2x minus 3 all over x times x plus 1 times x plus 3. Let's combine our like terms in the numerator. We end up with x squared plus x minus 3 all over x times x plus 1 times x plus 3. Then you ask yourself, can you factor the numerator? Can that numerator be factored? Factors of negative 3 such that we add them and get positive 1.
2 and
Is
-1.
2, there we go, see? Got to answer those 2 questions. I saw you answering them before, right? There's not. Can't factor it. All right, so I want y'all to look. There is going to be a break in the graph where x is 0, because 0 would make this denominator equal to 0. And at -1, because that would make this term equal 0. And at -3, because that would make this term equal to 0. If any one of these terms is equal to 0, the entire denominator is 0, and therefore the fraction is undefined. Undefined. It's not plotted on a coordinate system. It is undefined.